I'll be explaining part 1 in lab 2. So in this prelim work, we set 4 and 1, which is the sent input for 4, and 1 is the reset, which is the SD and RD. SD and RD is always set to high based on the data sheet. And we have 2 and 3. 2 is data input and 3 is input, which is connected over there. And this is the 4 and 1, which is the SD and RD. And we have 5, which is connected to the die module, which is over here. And we have 6, which is connected to the LED. Now let's test the circuit with some combinations. So now we have LL, which is D is low and clock is low. So if both 2 and 3 is low, the Q naught should be high and the die module should be low, which is the Q. And if we set the D to high and clock to low, we should get Q low and Q naught high. So if we set this one to high, we get this is the Q to be low and Q naught to be high, which is correct. Now if we check that it is high, we should get Q high and Q naught low. So Q high and Q naught low, which is right. Now we check high low, which is D is high and clock is low. So we get the Q high and Q naught low. So the Q is high and Q naught is low. Now we check the D is low and clock is low. We should get the high, the Q is as high and Q naught as low, which is right. Q as high and Q naught as low. So we check that D is low and clock is high. So we set the clock to high, and we should get Q low and Q naught high. So Q is low, Q naught is high, which is right. Now we check that D is low and clock is low, and we get Q low and Q naught high, which is right. And now we set D is high and clock is low. D is high and clock is low, so we get Q is low and Q naught is high, which is right. Now we check that D and clock is low, so both of them are low, so we get Q as low and Q naught as high, which is right. Now we check that D is high and clock is low, so D is high for pin 2, so we get Q is low and Q naught is high, which is right. Now we check that D is high and clock is high, so we get so this is D is high and clock is high, so we get Q is high and Q naught is low, which is right. So that's it for my part. Thank you. Explaining part 2 in lab 2. So in this circuit we set the SD and RD to be high, just like in the data sheet. So here we set the switch to be high for all the cases. Then we measure the clock module to be 500 kilohertz, and we measure the frequency for channel 1 to be we measure the frequency for channel 1 to be 500 kilohertz and for channel 2 to be 250 kilohertz, just as we expected in the prelim work to be 250 kilohertz. So for the expected frequency that we got, we designed a circuit which has an input of 500 kilohertz and the Q naught which goes back to D, and we used present values to come up with this diagram, which is half of the frequency. That's why we got 250 kilohertz, which is half of 500 kilohertz.
Today I'm going to explain part 3 of lab 2. So for part 3, we need to construct the circuit where the count will be from 1 to 6, and when it reaches 6, the LED will switch off. So this is the truth table. So this is 1, 2, 3, 4, 5 and 6. It's 0, so it will be turned off. And this is the 161 IC, and these are the NAND gates which represent the 00 IC. So I've set the clock module to 1 Hz, and this is the on-off switch. So first, when I turn it on, this is 1, this is 2, 3, 4, 5 and 6, and this turns off. So this time I'm gonna turn the clock module to 500 kilohertz. And then when I press the run stop switch, every time I press it, it's gonna show a random number. So I'm gonna explain part 5. So we have combined part 3 and 4 to produce part 5. So that's why therefore there isn't part 4. So this is the schematic for part 5. So now we're only interested in the die module. So if you see over here, when I run the button, it's like 2, 3, 4, 5 and 6. It starts over again. 1, 2, 3, 4, 5, 6. Now I've generated a random number for the die module when I turn the clock module to 20 Hz. So if you look over here, it's random number 1, random number 2, random number 4, 3, 1, 3, 6.